So for this video, we're going to look at how graphing cosecant looks. So keep in mind, cosecant is the reciprocal of sine. So we flip the values for sine. So how is that related to a graph? So you can go through and do these if you want, but we're just actually going to go to this GeoGebra website. If you type that in, this is what will come up. So let's first look at the sine function. So what this does, if you check off one of these boxes, it'll graph. So this is like your unit circle here, and it graphs all the points around the unit circle. It's kind of cool. So it does it point by point, so that's why it's not connected, but we all know that the sine graph should be connected. So here's my sine curve. So what does cosecant look like? So now we're going to graph cosecant. So point by point, you'll see. So cosecant is what's in red. I'm just going to go over it so it picks up on a couple more points. So here is sine. Cosecant is just these red curves. So we have a curve up and then a curve down. So as you can see here, just going to graph that again. It's separated into two parts. So for these graphs, we're also going to have asymptotes where you have values that are undefined that we don't cross over. So if I graph the sine function again, where there's a maximum on the sine is a minimum for cosecant, where there's a minimum on sine is a maximum for cosecant. So kind of interesting. The cosecant function does go on forever. So if I go over to Desmos, here you can see the cosecant function. So if I zoom it out, it goes on forever. So it's these little curves going up and down. So this is one from 0 to 2 pi, so 0 to 6.28 is one full period, one full cycle. So we have a piece that goes up and then a piece that goes down. So that would be one cycle, and then it starts the second cycle, piece that goes up, piece that goes down. So here the period is 2 pi. So we have one here, and then we have an asymptote at the y-axis, an asymptote in between at pi, and then an asymptote at 2 pi. So at multiples of pi, we will have asymptotes. So going back to this, if we wanted to draw this out, we would need 3 asymptotes. So asymptote, we'll skip, asymptote, skip, asymptote. So let's say that this is pi and this is 2 pi. And then we would have our curve up on the first one and the curve down in the second. Let me draw this one a little bit better so we can really see it. There we go. So your arrows go along the asymptotes, not crossing, not touching them. So what do you notice about cosecant compared to sine? So I kind of talked a little bit about some of this stuff in the video, or when we were looking at it on Desmos. So the sine function is continuous. It goes on forever, whereas cosecant is not. So that would be a difference. The minimum of this graph here is the maximum of sine and vice versa. So you could write that down as well. And then here, so we have some information. The period is 2 pi. The vertical asymptotes are on multiples of pi. The range, so how for y, what values of y? So this goes from 1 to infinity and from -1 to infinity, but not anything between 1 to -1. So our y values are between -1 and 1. And then we have a local minimum. So what that, it's a relative minimum, same thing. So a minimum looks like a bottom of a bowl. So that would be here. So that is at pi over 2, 1, because it's halfway between 0 and pi. And our local max or relative max is at 1.5 pi. So this is pi, this is 2 pi. So this would be 1.5 pi, which we can call 3 pi over 2, -1.